Hello guys, another problem for particles in 3D. So basically three forces, and you have the three forces here, one, two, three. They say that they are acting on this little ring here, determine the magnitude and coordinate direction angles of the resultant force. Or, in other words, determine the resultant force. And that includes the magnitude and direction, and the direction can be given as either the unit vector or the coordinate direction angles for the force. Uh, okay, let's first study what is happening here. Obviously, these are meant to be projection vectors, projection angles. That means that this is here on top. We have to bring it down to this part, and then we have to bring it down to the other axis. That's what's happening here. So the force is somehow inclined in the space here. You have to bring it down to this line, which is like the shadow casted by this force. If you put a light bulb on top of it or a light source on top of it, it casts this shadow, right? So this is one of the components parallel to this one. But if you want to find the x component and the y component, you're gonna need to bring that projection to the other axis. So basically, for the force 2, and I started the force 2 because it was just in front of me. It was easier, or was the first one that I saw. Let me see if I have another pen because this pen is really bad. I'm gonna throw it away so I don't waste time again. How come I have like 300,000 of these things? There you go. I have my pens here. More pens. And this one goes to the trash. So if I want to find the projection of this force, it will be this component, and this component. The easiest one, obviously, will be this one. But we need this angle, and this angle is not provided. This is one of the things that I don't like about this problem, is the drawing is not clear. It's not really the best drawing, because you see this 60 here, the way it is expressed, it looks like it's one of the coordinate direction angles. And no, this is just the angle that the force and the axis made correctly. So that could be one of the projection angles, but it's not. And this 60 is just to tell you that this angle here is 30 degrees. But it's not really well written right there, at least in my opinion. The force 3 goes entirely into the z-axis, and the force 1, then you have this alpha with the x-axis, alpha, beta, and gamma with the y-axis. So we have all of them. So let's start with force 1. What do we know about force 1? We have the magnitude, and we have the cosine director angle. So basically we have the force 1 in Cartesian. Would be the magnitude, 400, multiplied by cosine alpha, cosine 120 in the I direction, cosine beta, cosine 45 degrees in the J direction, and cosine gamma here, cosine gamma here in the K direction or in the Z direction. And that basically will be 400 cosine 120, so that will be negative 200i, negative 200i, 400 times cosine 45, that will be 282.84 J, plus cosine 60, cosine is the same but it's positive 200 K. That will be the force 1 in Cartesian notation, and the units from time to time, remember to copy the units. Now for the force 2. Okay, for the force 2, what do we have about the force 2? We have the magnitude of the force, and we have projection angles, which are these ones here. You can do this in with one intermediate step, which is calculating these ones if you want to. You you can do that because no, it doesn't hurt you. It doesn't take too much time. So this projection, once again, remember this force is like that, and it's just being projected over the XY plane in this way. So this angle is 30 degrees. This angle here is 90 degrees. How do you know this is 90 degrees? Because this force goes in the XY plane and this goes in the Z axis. That's how you know this is the right angle. So basically we can say that this here, this line, this projection, this intermediate force, if you will, that would be 500 cosine 30, that one, that line. But now, if you need to project that over the x-axis, right here, we need, this is another 30 degrees. There are two different 30 degrees. This 30 degree is because of that. And now, this one is just going to be this force. We're going to get that force. I'm going to bring it back to the axis like that. I'm going to project that force over the axis. And if I project this force over the axis, basically it's going to be the value of this line, which is the hypotenuse, because right now the right angle is here, this force, and that force is, remember, 500 cosine 30, multiplied by the cosine of this angle. But the cosine of this angle is also 30 degrees, so cosine 30 again. That will be the I component of that force. Now, the in the y direction, this is the component of the y direction. So basically what I'm doing is I'm getting this force, and that force I'm bringing it to the projection with this axis here. And because this angle is 30 degrees as well, this is opposite to that angle, then that projection will be achieved by multiplying this times sine of 30 degrees. So that will be 500 cosine 30, which is this one. Now I'm multiplying by the sine of these angles, sine 30 degrees. And this projection, which is the easiest one, is just 500 sine 30 degrees, and that will give me that projection over there. Okay, so the force 2 will be basically 500 cosine 30, cosine 30 in the positive, it's pointing towards the positive x direction, so 500 cosine 30, cosine 30 degrees. And that will be 375. 375 I. This other force goes in Y, but if you pay close attention, it goes to the left, which is the opposite of positive for the Y-axis. So that's going to be negative. And be very careful with this negative. Be very careful with those directions, because those are usually the signs that mess everything up. So it's going to be 500 cosine 30 multiplied by sine 30. And that will be 216.51, 216.51 J. And last but not least, this one, which is going to be positive, positive, and it's going to be 500. I put 530 degrees. What is that? What is 530 degrees? It's 500 sine 30 degrees. So 500 times sine 30 degrees is 250 K. And this is the force to express in Cartesian notation, newtons. Force 3, the easiest one, because it goes only in one direction, which is K. So for force 3, I will put here 0I, 0J, and 100 K in Newton. And this is the force 3. Now, for finding the resultant force as a vector, we just add them up, like that. And notice that I did something here. I always do this because it simplifies my life a lot and minimize the opportunity to mess up, to have errors. I put all the i's on top of the i's, all the j's on top of the j's, and all the k's on top of the k's. You can put it in a line, but chances are that you're going to miss one, or you're going to miscount one of the forces. So if you had them one on top of the other, it's easier because now the resultant force is just negative 200 plus 375 in I plus 0, that's 175I. And then you have here 282 minus 216.51, 282.84 minus 216.51, 66.33 in J. And then you have 200 here, plus 250, plus 100 is 550 K Newton. And this is the resultant force. Now we need to find the cosine directors and we need to find the magnitude of the resultant force. Well, first the magnitude. How do you find the magnitude of the resultant force? You find the magnitude of resultant force by saying that the resultant force is equal to the square root of the summation of the square of the components. 175 squared plus 66.33 squared plus 550 squared. So the resultant force is going to be equal to square plus 550 square plus 175 square, and I'm going to take the square root, which is the same thing as elevated it to the 0.5, and that's going to be 580.97. 580.97 Newton. That's the magnitude of the force. If I need the unit vector of the force, okay, unit vector of the resultant force. How do you find the unit vector of the resultant force? It's the force divided by the magnitude. So I get the 175 divided by that value. 175 divided by that value. And then you get 0.301 I plus 66.33 divided by 580.97. This component divided by the magnitude, and that will be 0.1142 J, and then 550 K component divided by 580, 580.97. That's 0.947 9467 could be also K, and that's the unit vector. For some professors, this is the direction, and this is the magnitude. But if the problem is asking you, as it says here, coordinate direction angles, then remember the unit vector is just cosine alpha, cosine beta, cosine gamma. So alpha will be inverse cosine of the I component, and then alpha will be inverse cosine. You press cosine twice here to activate that, and that angle will be 72.48. Beta will be inverse cosine of the J component, press cosine twice, 0.1142, and that's 83.44 degrees. And gamma will be the inverse cosine of the K component. Inverse cosine of K component, 0.947, and that is 18.74. 18.74 degrees. Results: magnitude of the resultant force, coordinate direction angles. All of these problems are easy, guys. I mean, don't get just mesmerized by the angles and the distances and the shades and the things. Look, this is all the work that you have to do in order to complete that problem successfully. So see you next time, guys. Thank you for watching.